Okay, the first one that we're going to draw is our hydrogen molecule. Hydrogen is a diatomic molecule. So all we have here is 2 atoms of hydrogen. First thing that we're going to do is write down the element symbol, and that will represent our nucleus of hydrogen. And now the amount of valence electrons that hydrogen has, well, you can obtain that by looking at the periodic chart. It's in group 1A, so it has 1 valence electron, 1 dot. A second hydrogen atom, we have to bond to this, and that also has 1 valence electron. And I'm going to draw that as an X. Now, hydrogen needs 2 to be stable and happy and have the same number of electrons as the noble gas next door, helium. Hydrogen is going to borrow 1 from this atom, and in turn, though, if you borrow 1, you have to loan 1 back. So this hydrogen borrowed 1 over to hydrogen, and this one is going to loan 1 back. So this hydrogen has 2 electrons within its boundary, and this hydrogen also has 2 electrons within its boundary, and they have actually overlapped their orbitals where those unpaired electrons were, and forming a neutral molecule. So we generally call this the Lewis dot structure. And then another thing that we're going to do is draw something called a structural formula. We're going to have the element symbol. We're going to use a dash to represent the 2 electrons that are in that bond, and then the other atom. So the structural formula will use a dash to represent the electrons that are in the bond, and that's called a single covalent bond. Now, they say single because there's only 1 pair of electrons involved in the bond, and we know that 1 pair of electrons is a total of 2 electrons involved, but 1 pair of electrons is referring to a single covalent bond. Covalent means sharing, so 1 pair of electrons are being shared in this bond. To do another structural formula, I'm going to take bromine next. There's 2 atoms of bromine. So I'm going to write 2 atoms down. The next thing we're going to do is look to find out how many valence electrons they have. Bromine is a halogen in group 7A. It has 7 valence electrons. Again, 7 valence electrons on 1 atom, and the other atom of bromine also has 7 valence electrons. I'm going to do this bromine atoms as X's so I can distinguish whose are whose. 1, 2, 3, 4, 5, 6, 7. Now if you notice, I've left the empty area on the side closest to where I know it's going to bond, as well as this bromine. I left an empty spot over here because I know it's going to be bonding over here to this bromine. So this bromine now has 7. It wants 1 more, so it's going to borrow 1 from this bromine over here. But basic rule of thumb, if it borrows 1, then this bromine is going to be able to borrow 1 back. So this bromine ends up having 1, 2, 3, 4, 5, 6, 7, and 8. So if we draw our circle around all of the octet electrons that the bromine has now achieved by overlapping the orbital, you have a bromine atom, single covalently bonded to the second bromine atom. Now the other thing that we're going to put on the structural formula, all of these electrons that are left unshared by anybody else, we need to include these on the structural formula. This also has 6. And the unshared electrons are really going to be of great importance later on when we look at the Vesper theory and actually determine the geometric molecular shape of a lot of compounds that may have just more than 2 atoms. Obviously 2 atoms, it can only be linear because they exist side by side. Our third one, let's do NH3. Okay, the last one we're going to do is NH3. Now NH3 has more than just 2 atoms involved in the chemical formula. So remember, the first element that usually appears in the chemical formula is our middleman, the person in the middle, the atom in the middle, and the other atoms are going to be bonded to it. So we're going to put nitrogen in the middle. We're going to draw our Lewis dot structure. Nitrogen, if you look on the periodic chart, it's in group 5A. So it has 5 valence electrons, which requires us to do 5 dots. So there's our 5. Now we have 3 hydrogens to place around this middleman. Now I'm going to put the hydrogens in the areas that have those empty spots available for nitrogen. I'm going to set them over here because there's already a pair of electrons over here. So just to neaten things up a little bit, 1 hydrogen here, and take a look and see how many valence electrons hydrogen has. On your periodic table, it's in group 1A, so it has 1 valence electron. There it is with an X. Another hydrogen, also 1 valence electron. Another hydrogen, 1 valence electron. Now let's make the hydrogens happy first. Hydrogen we know only needs to borrow 1 to have a complete set of 2. But if it borrows 1 from nitrogen, it's going to loan 1 back. This hydrogen also is going to borrow 1. In return, we'll loan 1 back. This hydrogen will borrow 1 from nitrogen, but in return, it will share 1 back. Nitrogen then has, if you count, and again, you know that nitrogen wants to achieve an octet, 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. So it has achieved its octet by borrowing an electron from each of those hydrogens. And we're done. So that's our Lewis dot structure. Now we're going to draw the structural formula. Nitrogen is in the middle. Now we have a hydrogen up here. Hydrogen over here. Hydrogen down here. 2 electrons are represented by each dash. And nitrogen, if you take a look, has 2 electrons that are not being shared by anybody, left over, remaining unshared, and we really need to incorporate those in the chemical formula, and that'll tell us a lot about their geometric shape when we use the VSEPR theory.